All right, so today we are going to learn how to add two numbers. Okay, but really this isn't about adding numbers, this is about getting familiar with linked lists. So we have linked lists representing non-negative integers, but the digits are stored in reverse order. And each node contains a digit and we want to add them up. So like if we look here at these two lists that we're adding, 2, 4, 3, this represents the number 342. 5, 6, 4, this represents the number 465. Add them together and you get 807. And if you think about this, this is sort of the way that we go about adding things, is that we start with the least significant digits and we move to the most significant digits. So even though these numbers look backwards written out like this, it is intuitive in terms of the process of how we actually add. But let's think through how we would solve this problem. Basically, you could just like loop through the two lists and just take the two values, add them together, and put that new value in your new list, and just move on to the next two values, add them together, add those to the new list, and you'll have to make sure to like link everything up, and then you just do this and that will get you the resulting list. The only thing that we need to be careful of here is that we need to make sure that we are dealing with carrying digits. So what happens like when we get here? So 6 and 4, this makes 10. So then we want to not put a 10 here, but we want to put a 0 and carry the 1 to the next digit and then add these up. And then we would get 4 plus 3 plus 1 gives us 8. And so really all carrying is if we're at a node and we get a number that's 10 or higher, then we just get the first digit of that two-digit number, and then we keep track of the fact that we are carrying a 1, and then on the next node we just add that 1. And that's all we have to do. Okay, so let's go ahead and loop through how we would do this. Okay, so it's basically just going through this process. So we would start and we would make a head, and so here, I want to make sure that we're making this correct. Okay, so we're going to make the head, and this is just going to be, we're just going to make a new list node. Actually, I'm going to call this pre-head, because we came across this in like a previous exercise where you have to, the most natural way to like create a new linked list is to sort of create it in the middle in a sense. And so you need to create a node at the start that's just there to initiate the linked list. And then what you're actually going to, the head of the actual linked list that you want to return is going to be the thing that comes after this sort of initiation node. And so that's why I'm going to call it the pre-head, because this is going to be, prehead.next is going to be the head of the linked list that we actually want to return. Okay, so so we create the prehead for initializing the linked list, and then we are going to keep track of the current list, or the current node, which I will call cur, and we'll just set it to the prehead for now. And carry is going to be equal to 0 because carry is going to be a 1 when we need to carry a digit, and so by default we won't. Okay, so then we're going to loop through L1 and L2 until we get to the end of both. So we're going to say while L1 or L2. because so long as at least one of them still has values, we want to keep going. Okay, so we can do val1 equals L1 dot val if L1 else 0. And why is this? Okay, so basically what we want to do, let me actually write this code in not linear order. We're going to take the value of the next node should be the value of L1 plus the value of L2 plus 1 if we are carrying anything. Okay, so for val1, we want this to be the value of L1, but L1, we may have run out of L1 by now, so L1 might be none. So instead of just getting the val, we have to say L1.val if L1, otherwise just make it 0. And similarly, val2 is L2.val if L2 else 0. Okay, so then we do this. And now that I'm thinking about it, the way that I want to write this out, I was going to wait until the end of the code to sort of have this in here. But thinking about like how long we want to continue running this, we need to continue running this so long as we have values in. It's a little bit of unfortunate naming convention because I'm using the word value a lot, but as long as any of these three variables is non-zero, we want to keep going. So when could they be non-zero? If there are still values in the list L1, then it will not be 0. So that's why we have L1. If there are still values in the list L2, then this will not be 0, and so that's why we have L2. It could also be the case that we're still carrying something. So it could be the case that at the very end of the L1 and L2, we could get to the end. Let's say we're just adding 5 and 5. So then L1 and L2 are like linked lists, but they just contain a single node, and the value of each of those nodes is 5. Then 5 plus 5 is 10, and so we would put a 0 in this node. And then when we move on to the next digit, we've exhausted L1, so there's no more nodes there. We've exhausted L2, so there's no more nodes there. But we are still carrying a 1. And so we need to include that. And so we want to have L1 or L2, or if we are carrying a value, which will happen if carry is set equal to 1. Okay, so that's how this loop is going to work. And that's going to be the conditions for how long this loop runs. Okay, but this is the value that we want to use for the next node. But it's not the actual thing that we want to put in. The actual next digit that we want to use is going to be the value mod 10, because we only want the first digit. And then in terms of the possibility of there being 2 digits, we will set carry to be val floor division 10. Okay, and so what is this? This is this is the way that we do this, correct? Yes. Okay. So if we are carrying a digit, the maximum value of next digit is, the maximum value of val is 19, because val1 is a single digit, which can be up to 9. Val2 is a single digit, which could be up to 9, and we could be carrying at most 1 carry could be set to 1 rather than 0. And so in that maximal case, we have 19. So when we do floor division of val with 10, if val is strictly less than 10, then dividing by 10 is going to give us a decimal between 0, strictly less than 1. And so then taking the floor division will round down to 0. And so if val is strictly less than 10, then carry will be 0. But if val is at least 10 and at most 19, then val divided by 10 is going to be between 1 and 1.9. And so taking the floor of that will bring it down to 1, which is exactly what we want. If the value is between 10 and 19, then we want to carry the value 1. And so this formula does give us the correct value of carry that we want. Okay. Although I guess just thinking in terms of how we want to organize this code. Let's see here. For the next exercise, I sort of wrote out more comments in my notes, but I didn't do that here. So here we're going to say get next get next digit, and that's what we have here. And then what we need to do is we need to extend the linked list. And then the final thing we will do is prepare for next iteration in our loop. And setting the value of carry here is going to be part of that next iteration, because carry is going to be used in the next step of the loop, if we have a next step. But anyways, so we have the next digit, and now we want to extend our linked list. Okay, so we're going to, we have our current node, and we want to make a new node to come after it. And so it's going to be a new list node, and the value is going to be next digit. All right. And so we are making a new node with the digit that we want, and we are connecting the current node to it. And then when we prepare for the next iteration, we move the current node forward, so we will be looking at the next node. And we set carry here. The other thing that we need to do before we continue iterating is that we've used L1 and L2, and so we need to go to the next value in there. But we need to be careful. We can't just set L1 equal to L1.next and L2 equal to L2.next, because we might be at the end of one of these lists. So it could be the case that, do they have an example here? No. It could be the case that like L1 is much longer than L2. And so it could be the case that we run out of L2 and so the next node is none, or the value of L2 is none. And it might need to stay there for a while we work through the remainder of L1. And so what we need to do is, if L1, I don't like this. Okay, so we can say L1, we can set it to be L1.next if L1. Oh no, I don't think that works, because if L1 equals L1.next. What I was going to do is I'll write it out for L2. L2 equals L2 if L2.next, if L2 else L2. Because I could have just said else none, but in this else case, L2 is none, so we could just put L2. But the thing is here, I don't think this works because I think this will try to access L2.next even if L2 is null. And if L2 is null and we try to access L2.next, this is not going to work. So I can't quite remember how Python works, if it will check this condition first or if it will try to get this value first. If it tries to get this value first, then this code will not work. If it tries to get this, if it evaluates this first, then it will work. But anyways, that's all we need for the loop, and then we go through, and what are we going to return at the end? We want to return we want to return the sum as a linked list. So we want to return the head of the linked list, and again, we want the digits here to be in reverse order, so that the node has to refer to the least significant digit. And so that's going to be the first, that's going to be the head of this linked list. And so what we're going to return is the thing that comes after prehead. Because remember, prehead was just there to initiate the linked list. And so what we want to return is prehead.next. Okay, and so let's see if this works by running it. And it worked. Oh, so maybe this does work. L1 equals L1.next if L1 else L1. Let's just check this too. Okay, so this does work. Okay, but yeah, this is basically pretty much it for this exercise. We just have to make sure that we add the two numbers together. We deal with carrying the 1 if necessary. We deal with L1 and L2 possibly being none. We make sure to connect the nodes as needed, and then we return the head of the linked list that we have created, and that's about it.